Clifford Sanders Jr., currently Vice President of the Technology Automation Committee. Been involved with BDPA since the start of this millennium, so it's been almost 15 years. I currently work with the state of Michigan, the Detroit STD Surveillance Department in Midtown. So if you have an STD, we'll be looking for it.
That's what I wanted to hear.
That's so inviting.
Have STD, please come out and see us.
Hey, that is the Linux distro.
Yes.
That's the Linux distro.
That's a sales pitch, right?
Oh, hi, my name is Lamonda. I'm just curious about the Raspberry Pi, and I really want to learn more about it. I hope to never have to see you outside of this.
Yeah. Uh-oh, I knew that person was.
Oh, no.
Like, hey, hi.
So you're currently in IT or?
I have an information assurance degree.
Okay, so you're security?
Yes.
Ah.
Security, but I really like to, play around with hardware and stuff.
Okay.
Yeah.
So we definitely have to pull you more into BDP a little bit slower to pull some of your knowledge out, because security is definitely a hot area with everything going on, and every company getting invaded by whoever. Great.
Oh yeah, my name is Maurice Tedder. Yeah, I have a startup, robotic intelligence software, where I do like freelance app development. I work with robotics and things of that nature.
So you'll be the one we had to ask, how do you interface to the Arduino and the Raspberry Pi? So
Now I
you're-
work with the Arduino, not the Raspberry Pi.
Oh. So we have an expert over here we can tap.
Yeah, it sounds like a presenter.
Yes, yes. Right.
Hello, my name is Walter Gilbert. I've been involved with technology since birth. I have experience from the military. I was in the military for 3 years, and I was a power generator engineer. Outside, I've been involved with BDPA for more than 3 months now. And I was brought in by Beverly, and I'm just learning more about it and getting more involved.
My secret weapon. My name is Beverly Moore. I am the president of the Detroit chapter, and I'd like to say welcome to everyone. Glad to see you here. And I've been involved with BDPA for pretty much my entire career, a little over 30 years. And I'm just glad to see you here. And I'll talk about some other things towards the end if there's some time.
No, well, thanks for that.
Hi, my name is Sharon Doss, and my day job, I'm a IT project manager with Chrysler. I'm also part of the BDPA board where I serve with programs and professional development.
Hello, I'm William Bowen. I've been pretty much BDPA for almost 10 years now. Work full-time with federal government, and I work part-time in UD as an adjunct professor, teaching network security classes, as well as doing a little bit of programming. And then a little bit of programming myself on the side, and then here and there, I also do some personal training group acts.
And William, you're also involved with the National Society of Black Engineers too.
Exactly.
I work for the newest startup, HP Enterprise. If you've heard of the news, they're splitting. HP is splitting.
Yes.
Yes. So
There's
I just,
something going around.
yeah, it's a new thing. It used to be the merger and the consolidated house. Yeah, now it's.
So which part are you landing with, HP Enterprise? Which is,
I'm assuming I'll land with HP Enterprise, but we'll see.
Okay.
They got a year to finish the transaction, so we'll see. I just hope I have a job.
I know. Next
Well,
week.
they
Next week,
should, because
Chrysler.
unless, unlike a merger,
Yeah,
now you're gonna need extra people.
yeah, exactly. They got to
So that's one of-
duplicate a lot of
yeah.
stuff. So it's a good opportunity. I'm excited.
I know next week is the Fiat Chrysler Automobiles IPO. So,
Yeah.
change next week too.
Yeah, get my little pennies ready to
Did you
invest.
buy Alibaba?
No, I didn't.
They had their IPO, but they were on $90.
What do they do?
They're the giant retailer in China, so they're bigger than eBay, PayPal. They're like the biggest online retailer.
Amazon.
And Amazon, yeah, and even Amazon, so that's how big they are.
Wow. I missed that. I'll have to catch them on the way down.
Yeah, I'm way back up. Okay, well, I'd like to thank everybody. This is the restart of the Technology Automation Committee meetings. We've been in hiatus for a little while, but I said it's time to get back, get everything going. You know, Detroit's coming back, so it's time to bring back the tech. Quicken Loans is doing their thing, and Techtown, just the new Techtown look, so it's like, okay, let me give it a go again. So today we're just going to talk about, give an overview of what I call low-cost computing using the Raspberry Pi, and I'm going to mention some of the other single-board computing platforms out there. But first, I'd like to talk about Technology Automation Committee. This committee is, I like to say, is for the geeks. If you want to get into tech, learn about tech, talk about tech, this is the group inside BDPA that's what we do.
Get down and dirty.
Get down and dirty. We try to go below the hood of what technology is going on and try to do some hands-on eventually. In the past, we've set up networks at churches and other nonprofits. So again, I would like to get more into that, learning how to apply the technology that's out there and introducing more us to what's out there too, because sometimes when you work, you can't really touch all the technology. That you may be unfortunately doing just one thing, maybe a program, but you like to learn about virtualization. Well, they'll let you touch the servers. So here at TAC, this is where we try to get people together. I do some presenting. I'd like to get other people's expertise and do presenting on what they're good at. And we learn from each other, because this is where you get to ask questions on anything. Nothing's out of bounds here. So again, this is a part of the BDPA, the Black Pricing Association, and we're an IT organization working to bring more people of color and women into the IT field. To be a part of TAC, you do not have to be a member of BDPA yet, but we do encourage you to become a member, because there's a lot of benefits to becoming a member of BDPA. Especially, we have a lot of job contacts. So if you come to our meeting that's next Thursday, is our information exchange meeting, we'll have HP talking about their cloud platform, Helium. So that should be exciting, and we think we should have a couple of recruiters in the audience too. So it's a good time to you can mingle, mix and mingle, and find out what's going on in the area, and see if it's time for you to move up, or maybe do a lateral moving subject you would like to get into. So today's agenda, we're just going to talk about overview of the different popular platforms. There's a lot of them out there now, but we're just going to go over a few of the popular platforms that are out there that's available that you can play with. Then we have a video overview of the Raspberry Pi and Arduino system. These are the two popular systems that are being used in the maker movement, as let me explain the maker movement. The maker movement is kind of this new wave of manufacturing and building things, but more at a small scale. It's more of people going out there and building either creative projects from jewelry, clothing, and then even like Maurice does, robotics. So there's this new movement going on that's getting people, especially Americans, to start building again and not become so much a producer. And one company there, which I would love to get them to talk about it, they do 3D printing.
Just found that.
And that's really the next hot area. So keep your eye out. I'm going to try to talk to the owner of Monolith and see if we can bring him in to talk about 3D printing, because it's definitely the new wave of manufacturing. And let's see. Next, we'll go over the basic setup of the Raspberry Pi and Arduino system. Raspberry Pi is a little bit more of a setup because it is a Linux-based system, so it takes a little bit more to get it going. Arduino, it's more of plug and play. You just plug it in and program it, away it goes. And then finally, just a list of what you can do with these devices. That, okay, you have all this power, what can you really do with it? So I have a list, and I will show a couple of demos on the Raspberry Pi, what you can do. Now, some of your popular single board platforms is the Raspberry Pi, which I will pass this one around because it's died. This is the Model B Plus, and that's the last generation of Raspberry Pi that's going to be produced. And on this model, on that latest model, they've added more USB ports and more I/O ports to it. The other contender is what they call the Banana Pi. It's basically a Raspberry Pi clone, but they've upped the processing power. It has a dual-core processor in it, a little more memory. So it's if you need a little more horsepower, the Banana Pi is the kind of the step up. And the next contender is called the BeagleBone Black. This is also a single-board computer. It is definitely getting more traction in the last few months. It's been out there about just as long as Raspberry Pi. And Intel, well, of course, they have a couple of platforms out there too. And of course, the Arduino. It's not a computer, it's more of a microcontroller. So you program, but it's used to actually control physical devices, which your Raspberry Pi can do, but the Arduino is more designed to handle truly variable outputs. Unlike computers on and off, the Arduino can go and vary its control method. So when you want to dim a bulb, it can dim it. Raspberry Pi is one to turn it on. And I have a link here, which I will put this presentation up on the website, just from the Electronic Design News. They were listing some of the 10 boards out there also. They list the Raspberry Pi Beagle board. And there's a couple others not as popular. And most of the hardware is open source hardware. Meaning, if you want to, you can go online, download the specs, build your own version, and sell it. So that's one of the advantages of a lot of the Raspberry Pi, BeagleBone, and Arduino. They're open software, or open hardware in a sense. And especially on the Arduino platform, there's a ton of workalikes out there. Because people say, well, I want it this small. So they got a smaller version and added features and pulled out features for special purpose use. And RISC-based. Basically, these are all what they call RISC-based processors. RISC stands for Reduced Instruction Set Computing. And really what this means, these processors have been optimized to, for their assembly language code to execute the fewest clock cycles. Unlike a normal computer, which is called a complex instruction set, in which it may take many clock cycles to run a operation command, RISC processor is designed to do it in the smallest period of time. So even though it says it's a reduced instruction set, or it's a small instruction set, that's not really true. It's really the fact that their instruction sets many times are even more complex than you can tell, but they've been optimized to run as fast as possible. Now, of course, the first is the Raspberry Pi B model and B plus. There is also the A, but that's the older one. I don't think you can buy the B one. And the Raspberry Pi is based on the ARM processor. It's clocked at 700 megahertz, but you can overclock it up to maybe a gigahertz. You're pushing it, but it will overclock. It has only a 512K of RAM built in. The B model, which I have here, which I've plugged up, it comes with 2 USB ports, and the one that's going around, that's the B plus, that has 4 USB ports on it. Same memory, and then the B plus has more what they call GPIO pins, so you can actually control more devices with it. And as you can see here, it's a Linux-based machine, so it supports Linux distros that have been recompiled to run on the Raspberry Pi. So the most popular version is the Raspbian Linux version. And also, they have a FreeBSD, as you can see here. This RISC OS one's a weird one. It's there, but I guess it's more for experimenters to play with. And let's see, the memory on here. Unlike a computer, you have a hard drive. These are all driven by SD cards. And basically, you need to use what they call the 10x, the high-speed cards, because that's your whole memory. That's your hard drive, your SD card. Both models will support up to 32 gigabytes. The B Plus uses the micro SD card, and the older B one uses the full-size cards. So that's basically the only difference in the two. The next one is the Banana Pi, and its main feature is that it uses a Cortex A7 dual-core processor, similar to what Apple has used on their phones. But other than that, it's basically Raspberry Pi with a little more horsepower. It's slowly catching up, but we'll have to wait and see because everyone's waiting for the next version of Raspberry Pi to come out in 2015. But since it's compatible, you can run basically all your old, any software on the Raspberry Pi will run on this version also. And again, I have links here. I'll put this on the website so you can don't write on anything. Just download this presentation. The next device is called the BeagleBone Black. It is again a single board computer. This is based on the Texas Instruments microprocessor. Definitely a little more power than the Raspberry Pi. Again, it runs certain select versions of Linux distributions out there. And one thing I was able to see, remember a couple weeks ago we had a D-Electric event in downtown Detroit. One of the displays they made was this big giant mannequin. He had LEDs down for its hair. They used the BeagleBone Black to control all the lighting functions inside this mannequin. I asked him why not a Raspberry Pi. He said this needed a little more power. So this was actually too much, but the Raspberry Pi was not enough for him to control the LEDs in the way he wanted to do it. And then there's a lot of support between BeagleBone Black and Raspberry Pi out there, so there's a lot of good user support forums and websites on information. So this is definitely more for like Maurice, who does playing around with stuff. This would be more if you want to do a little more high power computing. This one is, of course, Intel's entree into the small computing environment. I'm not sure this is fully open hardware, but it is compatible with the Arduino system. Like I said, I haven't heard much about it. I think they've just been pushing it for the last few months, so its user support is kind of small right now, waiting to see if this really catches on. But since you have to always include Intel, because when they get in something, they'll try to dominate it. But I said, unfortunately, I don't think they're going to dominate this very much. But we'll wait to see about this. But that's another platform that's available for you to play. And the last one is the Arduino. Let me pass that one. Now this one is not truly a computer, it's more of a microcontroller. So this is a system you use to control your robotics and other outside devices, home automation. So this is more of your core for those type of controls, because its function is to do analog and digital outputs. Unlike the Raspberry Pi, BeagleBone, those are more your digital outputs. This one does have a way to take in digital inputs and analog inputs and analog outputs. Not as powerful, but it doesn't need to be. It's only 16 megahertz processor compared to like 700 on this. But for the job it's doing and what it's designed to do, it's plenty of power for controlling things. And what's nice is because the two user environments have, Arduino has a big following, Raspberry Pi, they're compatible. So they've made ways to combine these systems together. So just if you have that, you say, well, we want to add a computer. Well, there may be someone out there who's done something similar, and you can use their work to help improve your design using the Arduino system. Now, why the Raspberry Pi? Well, one thing, it's cheap. It's only $35 from Microsoft. So that's just the computer. Now, you have to buy, of course, a keyboard and mouse, but you're more likely to have those lying around. Case is only $8, but the computing platform itself is $35. Virtually disposable.
What is the case?
Actually, you can see this one has the piece of the case, and where's the top? And people have made their cases with 3D printers, wood. I mean, you can place it in anything you want, because there's no fan. So all you have to do is make sure there's a decent airflow. It doesn't get very hot. Because it shows here, it's a power consumption about the same as a cell phone. And once you get it running, you can pull your monitor and keyboard. And it's no moving parts, which is great. So the only thing you have to worry about is static. Is a static electricity. The only thing that's going to reharness these devices.
Can I ask you a question about
Yes, go right here.
When you say pull your monitor and keyboard, can that be applied to like an iPad as well that has the monitor and the keyboard integrated? Or are you talking about a Windows arrangement?
Well, what I'm talking about is what they call headless running. So once you get it configured and running, you don't need the keyboard or mouse, because now you can you can just tell a remote into each of these little boxes. Being Linux, you use SHH and just put an IP address. You can access all your commands and anything from a remote system.
Okay, I don't know what you mean by that.
Meaning like, say if I had this set up, once I pull the keyboard and mouse, but as long as a network connection and an IP address, I can then come up on my system, either using Windows Terminal Server or the equivalent Linux, put an IP address in and remote into that computer, log in, and see what's going on, or stop systems, or whatever I need to do.
So can you accomplish this with an Android or an iPad device?
If you rooted your Android and you can get to the terminal service, yes, you could actually. If you're on a wireless network, you wirelessly connect and come back to your Raspberry Pi that way. And Apple, again, too, if you have busted in so you can get to the terminal part, you could also remote into your system. So it just comes in handy. So what, say if you want to set this up and just put it in the closet. So once you set it up and it has an internet connection, you never have to plug in a keyboard or monitor again, because you can just remote in and see what's going on.
Okay. So you can actually access it wirelessly?
Yes, if you get the right wireless dongle. Now that's the only problem with Linux. A lot of the hardware, the vendors haven't written the drivers. That's the best way to say it. It's not that it can't handle the Wi-Fi, just that there's no driver for it. Linux can't do anything with it. But they have an extensive list on the internet of what dongles you can buy that are compatible with the Raspberry Pi, compatible with the Eagle Bone Flag. So basically what you're going to buy, just go under the forums and look up which Wi-Fi adapters to purchase.
And that's what it takes, a Wi-Fi adapter?
Yeah, Wi-Fi or cable. They both have cable input too. So both have Ethernet 100 base. Again, this is just a quick diagram of what makes up your Raspberry Pi. Like I said, 700 megahertz processor. Like I said, you can overclock it to maybe a gig, but its stability is shaky. But I think I've overclocked this to 800. I've had no problem. Video card, built-in video, 512 RAM, 2 ports in the Model B. The B Plus has 4 ports. You have HDMI and the RCA audio ports, micro USB power, and the SD card reader. Full size on the older B, and the B Plus is a micro card reader on those. And again, it's up to, they said 32 gigabytes, but try 64, see what happens. It may not be able to. Depending on distribution you load, you may not see all of it or use all the whole card. And now I have a video presentation. This is going to work. If not, I'll just go to the website. Okay, we'll just go to the website directly. Because PowerPoint doesn't like. Yeah, that's like the pad.
Yeah, you might have to paste that into your URL.
Oh, that's, oops, I didn't connect. Secure, really, anything insecure. That's why I thought it auto-connected for a second.
You get Destiny for PS4? Got it at Walmart. Did you also pick up some better gaming skills? I didn't need those.
Alright, so this is an overview of the Raspberry Pi system.
Hello, I'm James Bruce with MakeUseOf.com, and today I'd like to give you an introduction to the Raspberry Pi, everything a beginner could possibly want to know. There are technically 2 models of Raspberry Pi, Model A and Model B. A costs $25 and was the original with only 256 megabytes of RAM and lacking a network port. Model B, on the other hand, has 512 meg of RAM and costs $35. It's the most commonly available, so most projects and tutorials assume you have a Model B. I would go for that. The first thing you should know about the Raspberry Pi is that it's essentially a mini computer with an ARM processor, memory, and graphical capabilities. And as such, it needs an operating system to run. Although a capable computer in its own right, the Pi won't run Windows. Instead, you'll find various flavors of Linux, and there's even a version of RISC OS and Amiga OS that have just been made to work on the Pi. Apologies if you weren't born in the 80s and have no idea what they are. The official operating system is a version of Debian Linux called Raspbian. And in nearly all of my own Raspberry Pi tutorials, which you'll find on MakeUseOf.com, it assumes you're running the latest version and a clean install of Raspbian. For trying things out, it's suggested you download the Noobs image, which is a graphical boot menu to open a couple of different OSs and try them out. Storage is one of the few things the Raspberry Pi doesn't include on board. Instead, you need to supply an SD card with an operating system image loaded onto it, and you should only use class 10 cards or better. Use a tool such as Win32 Disk Imager to burn the downloaded OS, or copy the Noobs files to a freshly, fat formatted card. Then when you're done, you can insert it into the Pi and boot. The Raspberry Pi is powered by micro USB, the same connector as many Android phones. It's recommended that you use a wall socket to provide a suitably high current, but depending on your model of computer, a standard USB port makes suffice, or a powered USB hub may work. For connectivity, every Pi is equipped with a built-in Ethernet interface up to 100 megabit speed. You can also plug in a compatible Wi-Fi interface like this, but whether or not your particular operating system supports it out of the box is another matter. 2 USB ports are supplied, but it's highly recommended that you get a powered USB hub, as the power supplied through the ports is quite low. You'll be fine if you're just plugging in a Wi-Fi adapter though. Video output is either through an analog RCA connection for old TVs, or through the more typical HDMI for HD TVs and monitors. The easiest way to get started is to simply plug in a keyboard and mouse to the USB ports and boot your choice of graphical environment. For many projects though, it's recommended you run the Raspberry Pi in a headless mode, which means you connect to it over the network from another computer by using the terminal command SSH. You can also use PuTTY application on Windows to do this. The default username and password when doing this is Pi and browser. Once logged in, you'll have remote command line access without the need for a monitor, keyboard and mouse connected to the Pi itself, though you'll have to do everything over the command line. There isn't a graphical environment. Interestingly, there's also a set of GPIO pins, which stands for General Input and Output, equivalent to the digital I/O pins of an Arduino. However, you need to be a lot more cautious when working with them because A, it's a lot easier to overload the Pi and burn it out, and it's more expensive, and B, it operates on a non-standard 3.3 volts, unlike the Arduino I/O pins, which are 5 volts. Since most sensors that you come across will want 5 volts, you'll need to use a variety of transistors or MOSFETs or other electronics to modify a given circuit. That's not to say electronics projects are difficult on the Pi, but if you're planning to use circuits designed for an Arduino, it might be better just to plug your Arduino into the USB port and interface with the circuit like that instead. You can use them both together. I also suggest you buy a case as soon as possible. There's a good variety of cases out there, and you can even 3D print one. The only thing you really need to know is whether or not you want an opening to access the GPIO ports. I picked up this clear case with GPIO access for about $10. Just like the Arduino, there's a number of accessory boards you can pick up and connect to, such as the GURT board or the Leica Explorer board, which adds a range of switches, LEDs, sensor connections and motor controllers. There's also mini LCD displays, and there's an official camera add-on, so you can actually use most USB webcams easily enough. There's not nearly as wide a range as there is of Arduino shields, for instance, but then if you need a particular shield, you can always hook up the Arduino and use it that way again. So what can you do with a Raspberry Pi? Well, as a few examples, last week I built a DIY Pogo plug, which is an anonymizing router that broadcasts a Wi-Fi network and then reroutes your communications through many layers of global Tor nodes. Effectively, it anonymizes everything you do on the internet. Next week, I'll try adapting this into a public Wi-Fi network, but with one minor adjustment. It'll replace any and all images with a similarly sized picture of a kitten. Seriously. Right now, I'm using my Pi as a controller for these cryptocurrency ASICs, which mine a few thousand Dogecoin each day. The cheap cost of the Pi combined with its extremely low power usage makes it ideal for this. Some people turn their Pi into a home theater PC for the living room, running either native Xbox Media Center or an optimized OpenALAC distro. There's even a dedicated ROM emulator called Pi Main, which can run pretty much anything up to about the Dreamcast generation of consoles. There's so much you can do with a Raspberry Pi, and there's a huge community out there to support you. What are you waiting for?
So let's give a nice overview of the Raspberry Pi. What's made the Raspberry Pi so popular, like I was explaining earlier, is that in Europe this is the big thing because it's used in the education system. That's what this has been used for as an education platform. To learn programming, learn how to interface with the outside world. Same thing with Arduino. Again, it's like Europe leads and we have to follow. So that, like I said, this website that I picked out, I'll make use of. The link is in the presentation. Good site to go to. They talk about Raspberry Pi, Arduino, Windows. A lot of good information out there. And then he was mentioned about the Arduino system. I have a video on that next, a little bit longer. But the Arduino's been around a little bit longer, have a little bit more user base out there because a lot of people love to build with it. And there's a ton of variations for the Arduino system.
So is this like an alternative to building a computer, like in the day when you go get this box, you go get all these cards and all that stuff? This is like an alternative.
It's an alternative, especially in the learning environment, because at $35, basically you're buying these for nothing at a case of, for well under $100, you have a system that's bulletproof, can use anywhere. I think I just read an article in Africa, someone made a system for that, he encased it because of the weather and bugs, but that's the only way they can get computers out there. And Arduino is cheap enough, so if it dies, okay, replace it. Take one of those notebooks out there and it dies, you're hurt. Even a Chromebook at $200, think of this, how many of these you can get in the classroom.
Yeah, I built like two desktops in my life, and each one of them came close to $800–900 when I bought all the parts and stuff to go with it. And then the hours it took to actually put everything in the box, and so this is interesting.
Yeah, because it's a small platform. It's great for learning. You learn Python, you learn Bash commands and Linux. So, and like I said, later on, you can learn some other security stuff to be running here too. Because of the size, just think of this, plant this in your network room to monitor your networking at different points.
So this is not something you would see in the corporate environment. This is more of a home stuff.
Yeah, it's some corporations, some companies, I would say small, medium businesses, yes. Large corporations, yeah, they got the money, they'll buy the giant system equipment and, dump $50,000 to $100,000. But if you don't have that type of change to throw around, this gives you an alternative to help monitor your network. And in schools, like something we may even look into for our HSCC program. You can run web server on here, and it runs Python.
Yeah, so basically, like the closer you actually come to that would be like the new keyboard bare bone PCs that came out from TAC. So basically, like the old school Commodores, where your PC is literally right there encased in the keyboard. $100. Only thing you got to buy for, of course, would be your hard drive and memory. And that's where it is. Actually, it does come with Wi-Fi. And actually, well, yes, I did go to Marseille and actually bought one because I saw it there. And it actually works with Linux right out of the box from Wi-Fi. You just got to buy your hard drive, stick a RAM, you're all set to go. So basically, it's a $150 computer.
Yeah, so that's what really made this popular. Is that in Europe they've used it as an educational learning platform to get kids more into the STEM program. And it's at its cost, you can let the kids play with it now. So if they blow it up, okay, you blew it up. Here's another one. Here, you blow up a netbook or your laptop. Schools ain't gonna like that. So it gives them a way to get more hands-on computing. And bring it there.
Who's gonna do it? Who's gonna make it happen? Discover a new energy source. Turn ocean waves into power. Design.
Hello everyone, this is James Bruce with MakeUseOf.com, and today I'm going to give you an absolute beginner's guide to this, the Arduino. Now, this video is divided into 3 logical parts. In the first, I'll talk about Arduino as a brand and a little background on what Arduino actually is. In the second part, I'll talk more specifically about the hardware and what it's capable of, as well as talk about shields and different Arduino versions and what you might find in an Arduino starter kit. Then in the third part, we'll take a look at the Arduino software, and I'll try to explain the structure of a program so you can understand some sample code and upload your first application. Let's get started. So, Arduino is a brand name. What you see here is the Arduino Uno model, the most widely distributed device. The hardware itself is an open source design, and all of the components are off the shelf. So what this means is that anyone can freely copy the design and sell their own clone or derivative product. In fact, you could put together your own Arduino just by purchasing all of the components individually, like this. In that sense, the Arduino is nothing unique, but it's the combination of the hardware design, the software, and the community around it which makes the Arduino so special. So you might be asking yourself, what is the point of the Arduino? Well, in the past, if you wanted to make something electronic, it would mean getting an electrical engineering degree or buying a kit which limited you to a single project. But with the advent of microcontrollers, making something complex with relatively few lines of computer code has become very easy. The Arduino, therefore, is a rapid prototyping tool. In short, you can make some really awesome things really easily. Okay, let's talk about the hardware for a bit. At the heart of the Arduino Uno is a microcontroller chip here, which is a little like a computer in that you can program it to do different things. There's also a timing crystal, a power regulator, and a USB interface here. Along the sides are a set of input and output pins. On this side are the digital I/O pins. Each of these can be programmed as either an input or an output, and they're digital in the sense that they can be on or off, high or low. Now, a few of these digital I/O pins are special. They're called PWM, and they are indicated with a little wavy line next to the pin number. What this means is that they can act like an analog output by sending pulses, for example, to dim an LED, while the other pins would only turn it on or off at full brightness. On this side are firstly the power connections, from which you can take 3.3 or 5 volts for your components and a ground line. Then you have 5 analog inputs. These are only input, and these would be connected to things like a microphone or a light sensor or a variable resistor. Basically, anything which gives a range of outputs would go into here. Now, the layout of these pins is standardized, which means you can buy upgrades of additional functionality called shields. And these shields then slot onto the Arduino. Here's an official Ethernet and SD card shield, for instance, which then gives you network access for your projects and additional storage space. Typically, these shields will use a few of the pins, and then the rest are duplicated on the shield. So again, you can stack more shields on top. There's also a small debug LED built into the Arduino on pin 13, which you can use to just test your programs quickly if you don't want to connect an external LED. So as I mentioned, the Arduino is open source, so there's lots of clones or DIY models out there. Functionally speaking, they're pretty much identical, the same components, the same features. The only difference is the price. With the original branded model, you're paying a premium, a charitable donation, if you will, that really goes towards research and outreach programs. Now you can tell it's an original by this gold-colored component, which was specially commissioned by the Arduino manufacturers, next to the USB socket here. This is a fake Arduino that I bought on eBay. It uses the Arduino Uno trademark, but you can tell it's a fake because the component next to the USB slot is green. These are standard off-the-shelf components, as opposed to the gold one, which was specially commissioned. Now, in my own online Arduino shop, I actually choose to supply a Fundrino clone model, purely because it's 1/3 of the price, which means the starter kits you get from me they're more bang for your buck, basically. We can put in an LED matrix, a LCD screen, lots of little extras that you wouldn't normally get with an original starter kit. Now, there's also different sizes of Arduino. You can get smaller ones or bigger ones. In this case, this is a Fundrino Mega. Now, this is compatible with the Arduino Uno in the sense that the shields can fit on here, but it also gives you a lot more input and output pins, and there's more memory on the card itself. The best way to get started with Arduino is to get a Arduino starter kit such as this one. Of course, as well as your basic Arduino or a Funduino clone, for instance, you're also going to find a breadboard, either full size such as this one or half size. Now what a breadboard is, basically something that you put components onto like this, and then you connect them together with jumper cables, jumper wires, which you should also get. Makes it very easy to connect things together quickly, put together a circuit. You should also look out for maybe a servo motor, which is a special kind of motor that lets you control exactly where it turns to, rather than just turning it on or off or at a certain speed. You'll probably also get some LEDs, and the resistors to go with them. Whenever you use an LED with the Arduino, it pretty much has to have a resistor in series with it. You also get some switches, like this, simple push button switches. Now if you're really lucky, you'll also find things like a dot matrix LED display, or even a segmented LED display like this. And perhaps even an LCD screen like this. So you're ready to get programming, and that's awesome. Connect your Arduino through the USB cable and let's get started. I'm going to assume you have a little programming experience here, so you understand terms such as variables and functions, or maybe methods at least. But don't worry if you've never specifically programmed in C language before, neither had I when I started. So this is the Arduino software package. It's also open source and comes with a good mix of example code. Let's go ahead and open up a basic Hello World app called Blink, which will flash the onboard LED on and off. So under examples, you'll find basics, Blink. Also down here, if you have any libraries installed, you'll find example programs for working with them. But here we go with basics Blink. So, the structure of an Arduino program is set, and you'll have to follow that if you want to write for the Arduino. First up, at the top of the program, well, you'll probably find some comments first, but then you'll find any variables, constants, and library imports. Libraries being extra bits of functionality that you can add, since there's no point reinventing the wheel, things like dealing with time or dates, or libraries for interacting with specific components like a temperature sensor. Constants, like the ones here, are variables which you'll be reusing throughout your program. By defining a constant, you make it easy to later adjust that and make the code more readable. So for instance, here we've defined an integer or a number called LED, and that's number 13. Now that relates to a pin number, so pin 13 is the onboard LED. And what that means is that whenever we tell the Arduino to do something to LED, we're actually just saying do it to pin 13. And if we were to change and put the LED on a different pin, then we'd only need to adjust the bit here that says 13 to 12 or whatever, rather than rewrite the entire program. So obviously in a short demo like this, it doesn't matter, but once you get into hundreds of lines of code, it's just good practice to define constants like that. Then we have two functions which every Arduino program must have. The first is setup. Now that runs once only when the Arduino is turned on or reset. So in this function, it's normal to instantiate any of the variables to a default value, to do any code that the libraries need to start working, or to specify whether a pin is an input or an output pin. Remember that digital pins can either be input or output, so you need to tell the Arduino which to use it as. In this case, we've said pin mode, LED, output, which should be fairly obvious. It says we want the pin called LED, remember that's pin 13, we want that to be an output pin as opposed to being an input pin. So that's what we've done in the setup routine. Now this is essential. You have to have a setup method, a setup function in every Arduino program. And you also need to have the loop. Now you can always write your own functions, of course, but you're certainly not limited to these. These are just two functions that absolutely must be in every Arduino program. So this is loop, which is exactly what it sounds like. The function will loop over and over and over again while your Arduino is on. So after the initial setup function has run once, the loop will keep going, it'll run once, it'll do it again, and then it'll do it again. Ideally, you want to keep this as short and simple as needed. So in this case, we're briefly turning on the LED, then we're going to wait. You do this with the delay. Delay is a bit of a hacky way of telling the Arduino to wait because it stops other code from executing, but it'll work for our purposes. So we're telling it to wait for 1,000 milliseconds, and then we're turning it off again. And then we're going to wait for another 1,000 milliseconds, at which point we'll go back to the start and do the whole thing again. thereby blinking the LED. So when you think you're done, it's a good idea to first compile with the tick button up here. And that will identify any possible errors in your code. But then you can upload using the arrow button next to it. Down here you'll see some basic stats on how much of the memory your program is using. Remember, the Arduino only has a specifically limited amount of memory, so if your program is too long, it simply won't fit on there, and you'll have to think about upgrading to a different sized Arduino or optimizing your program. So that's the basics of what you need to get started with the Arduino. I hope we can have more video tutorials like this in the future, but for now, please check out the rest of my Arduino tutorials on makeuself.com/tags/Arduino, and don't forget to subscribe to our YouTube channel. Thanks for watching.
So that video gave you a nice overview of Arduino, in which shows more of an education of why you need to learn programming. So this one has its own little programming language that's C-based, but it is very structured system because it's a controller. It has a preset of what it can do. Unlike computer, it has a wider range. So this has been definitely popular in the maker movement. They've used it to design, I think if they had one of the older 3D printers, that was actually used as a controller from the earlier models. And I believe that company now is producing a 3D printer too. So before it was more the people using this to build it themselves. Now the Arduino company is now building their own 3D printer. So it really shows the importance of why coding is now becoming such a hot thing, because software is everywhere. If you can control something, it's going to be done with software now. You're going to be talking to either some sort of controller or some computer or a mix of the two. So that's why there's been that big push in the STEM and also the STEAM movement, which is added arts into it. That was more of what the electric event had, in which they added arts to all this electronic and design component. So just run quickly through to set up your Raspberry Pi. You have to, of course, like I said in the video, you have to load an operating system on here. And the one that they recommend is the Noobs one, which is at the site there below. raspberrypi.org/downloads. It's Linux based, so it's command line driven, meaning you're going to use a lot of commands to get things done. It does have a graphical interface like Windows, which I'll show once I'll boot up the Raspberry Pi and the Raspberry mode to show you that, and another use that I have running on it to show the versatility of the Raspberry Pi. And of course, to get your image, you have a couple of ways. One is what they call, you can burn the image to the SD card. And when you get the software, the image, it's in a compressed format. And it said extension like .img.tg. So you may have to use WinZip to uncompress it first. And then you use the Win32 disk image if you're using a Windows machine to actually take that image and then install it onto the SD card. As I said, they recommend at least 8 gigs, class 10 or better. That's more for speed, because basically that is the hard drive of your machine, is the SD card. So you want it as fast as possible so that it doesn't slow the Raspberry Pi too much. Don't expect this to run ultra peppy, but it will run at a decent rate. And this is just the procedure to set up the Noobs version of the operating system. This is a little bit easier. You just download the zip file, unzip it, and then copy it over to your SD card. And this is just showing you to download, format your card. Depending on your card, Windows or Mac, it should just format it. If not, you can go out and download the special formatting software if you have any issues formatting your SD card. Then yes, it's a quick drag and drop. Pull the files over, copy it, plug it in. Then once you boot up, it goes through the install process. Now, if I had time, I would actually show you, but it takes a little bit while. But the screen that shows basically gives you a menu of setup, tells you if you want to expand the memory on the card. With this, if you use the news, download it does that automatically for you. Then it has an option if you want to overclock, if you want to play it, speed it up. And there's a couple of options you can play with, but basically once you select the version you're going to load, just let it install. It may take, I think it takes about about 20 minutes or so, depending on which version you run to install. This ready to go. And what's nice is because being an SD card, just turn on, unplug it, plug another version, which I'll show. I have it running on here as a media box version, and unplug it, plug in the normal version. So it's kind of like pulling out your hard drive and pulling in another hard drive and another operating system there. This is just some commands to use if you're, say you want to set up your Raspberry Pi more as a server, so you're going to do more specific application. This is just to remove a lot of the extra software you may not run. Scratch, that is the graphical programming interface for kids, which I can show that. That's how you can, that's a great way to teach youth how to program. And it just talks about some other things to remove, games. If you're not going to play, remove it. If you're going to use the web server, you don't need games. And it's just a quick view to show you how to check your interface connection. If you set up as a server, you need to give it a static IP address. And it's a command showing your routes. Similar to in Windows, we do IP config. This is the Linux version of giving you all the information. And then if you want to give a static IP, you have to go in. Of course, with Linux, you have to go into your text files and edit things. But it's a good thing to learn because in the industry, most of your web servers are Apache web servers, which are Linux-based. And a lot of things are Linux-based that people don't realize, like your phone. Android's Linux-based. It's just another distribution that they've modified. Your refrigerator, your car in some senses, some has some Linux in there. Watches, almost Linux has been embedded in a lot of devices now that you don't realize Linux is there. A lot of people would thought, oh, Windows everywhere. Well, actually, Linux is in a lot more devices. You just don't see it because the Linux kernel itself is not very big. Unlike Windows, which huge, was it 5 gigs? The kernel is maybe a gig or less. So the main program itself. But then with Linux, you bolt things on top. So you got the core, then you run the applications, word processor. So everything kind of bolts on top of the core. And like Windows, it's a giant thing, and then you bolt on stuff. Then you bolt your applications on. And it's just more of to replace your interface files. This is more for set up as a server. I just included that for reference purpose. And these are the keystrokes when you get your editor to save and get out of it. Now this is something you should do once you have loaded your whatever version of Linux you're going to run in your machine. You want to do what they call an update to the system, similar to Windows Update. So it goes out, checks for new revision, pulls them in, and then the next command, that's when you tell, okay, now upgrade, apply the updates. So very similar to Windows. Actually, says Windows took this from Linux. and add their flavor to it. And again, as you saw in the video, setting up the Arduino is pretty simple. You just basically plug it in, and you download the software from the Arduino site. And I can bring up the app. So that, that's all it takes. This is your main framework of programming for your Arduino. And basically go in, and this is where you have to select which type of board you're going to use. And you can see it's quite an extensive list of different Arduino types out there. And when you select it, you're on your way to program. And as they're saying, basic kit, this is one that you can buy from Make Magazine.
How would you know which one to select from that?
That's where you have to know which one you've purchased. So for like this Make Magazine, actually this one is the Arduino Uno. So basically I would select that one right there. And it defaulted to that anyway. So it depends on which model you buy. And you may have to even read the instructions because maybe, again, since this is open hardware, someone else can make it and rename it. You have to look at what their version is compatible with. And they'll tell you if it's compatible with the Uno, the Mega, the Pro. So it's just more of a little bit of research on that. But like no true operating system really loaded onto Arduino, unlike Raspberry Pi or BeagleBone, you got the local OS. It's basically ready to go. You're just programming your code, compiling it, and shooting it over and see what happens. And again, this is just showing the setup, which I just showed on the menu. You have to select your board. What happens if you select the wrong board? Something might happen. It won't harm it, you won't get your desired results. And that's one thing, this system you can actually play with. Oh, okay, wrong thing, but you haven't harmed anything. As long as you haven't hooked it up to something, some big mechanical device.
I mean, it's still like it's best to know exactly which one you use and that way.
Yeah, so that's why you almost want to play with it first before you really go to take it out in the wild and do something crazy with it.
Right.
Design a fire pit and try it. Oops, I put the wrong thing in there and it goes crazy.
It's supposed to be file driven, not
Right. Now, what can you do with these devices? There's a ton of things on Arduino, Raspberry Pi. It's almost limitless. If you can dream it up, you can do it just about. There's just a list of just a few things people have done. Use Arduino for a GPS clock. Raspberry Pi is a time server. See, that's something you can use in your corporate environment if you need a little time server somewhere in a remote office. The Raspberry Pi mounted calendar, basically what you do is you're going to use the web server, go to your Gmail account, bring your calendar, hook it to a monitor, boom, you have a calendar monitor, you have a calendar system. So it's something for home use so you can work, you should put up your calendar wherever. It's so small, you just stick it on the back, no one will notice it. Now another interesting, you could run voice over IP if you're asking with your Raspberry Pi. I've read it can do about maybe 10 lines, but it's all digital. You can't really hook it analog phones. And for network monitoring, you can run a couple of, there's a distribution out there for monitoring your systems. So you can go out there and do pings and check the health of your network. Surveillance camera. It's so small, and plus you can buy the little Raspberry Pi camera, which is very good. So you can mount this somewhere, do surveillance of your network cabinet rooms. So we want to make sure you keep those secure. And there's a cheap way of doing it. Why spend thousands of dollars if you only have one or two? Get a couple of Raspberry Pis and the camera, set it up, hook it to the network. You're now monitoring if anyone accesses your computer. Laser engraver, I've seen a plan for that, which again they've used Raspberry Pi and Arduino for those type of controlling environments. And I mentioned earlier in the video the onion router. So you want to go to anonymize yourself. Say if you're this can be handy maybe for if you're in Hong Kong and you're getting blocked from going out to the internet. That's what the onion router allows you to do, is to anonymize yourself so you don't look like you're coming from that country and try to go through the firewall. Also, this is used for Say if you want to watch content, say there's a Netflix, but it says, well, it's not available in the US. With this, you can tell, well, I'm now from England, and now you can get that content to you. Anyway, so for home use, yeah, definitely something like this, yeah, cheap, great, great project, because you can run on any big PC, but why do that? Just use this, set it up, unplug it, and away you go. Another list of articles there, just a list of just projects. I mean, people have done everything. I think the popular thing has been to put a camera on it and send it out to space. Take balloons and let it get to the edge of the atmosphere and take pictures of the Earth when it comes down. So that's definitely an education thing a lot of schools have done. And with this, you're not worried if you lose it. It's like, okay, if you lose it, or if you find it months later, you're not screaming. Like I've heard people who put their iPhones and set them in space. Okay, now you lost $600 if that something goes wrong.
Plus your data, whatever you have on it.
Right. Then also you can use this as a server. There's ways to turn this into a Joomla or WordPress web server. And that could be used for personal use or even for corporate environment. Maybe you want to show web pages just in certain areas. And maybe you don't want to hook to the network all the time. So basically set up, download your web server on it, put your content there, boom, now you have a little kiosk that you can set up anywhere. Also, Minecraft, which is a Microsoft product. It has software for that to run Minecraft, which is a very popular game with the youth. And also, this is a VPN server. And there's a distribution for penetration testing. So if you're going to do network security, you can use your little Raspberry Pi to
Pretty much
invade the network. But you're doing it as a white hat. As I said, you're getting permission. You're not going out and trying to hack, chase national banks.
Yeah, it's feeling better. There's still mine test, which is supposed to be the open source variant.
Right. Right, for Minecraft?
Yeah, it's mine test.
Yeah. As that was just one of the news articles where Microsoft spent, a couple of billion to buy Minecraft, which is like, okay, we're trying to figure out what Microsoft's going to do with that property.
Yeah.
Unlike Apple, who bought Beats, they're closing down Beats. Yes. The Beats headphone and the music service, they bought it, made Dre a pseudo billionaire. He didn't get there, but they're just closing it down. The rumor is they just bought it to get rid of competition.
Yeah.
Because there really wasn't,
HP has added it to several of their devices for whatever reason.
It's kind of a defeat meltdown in the zone because with the whole Beats by Dre little thing that they got going on, the NFL's already banned the whole Beats by Dre headphones. 3 hours before a game, 3 hours after a game, they can't be seen anymore. Then the NBA is talking about doing it, so that's just, I think personally, just trying to get rid of the whole Beats by Dre headphone thing.
So that's just a little tidbit on that.
That's
Of course, wearable computing, that's the big area that people have been trying to break through. Of course, Apple has the watch. And of course, Google Glasses.
So the Google Glasses, what does that mean? I mean, your glasses are now recording everything you see?
You could. With a Raspberry Pi, you could do that. You just put your Raspberry Pi on your side, a battery pack on this side, look like Batman with utility belts. And put a small camera. Now, unlike the Google Glass, which is not designed to record 8-10 seconds, you could record forever until you fill the SD card. And of course, this robotics, which is Maurice's area, he does a lot of that. So you've used Arduino for most of your robotics platform?
Yeah, because of the hardware, you know, controlling different hardware, servo motors and sensors and things like that. And then if I want like the power of the Raspberry Pi, I'll just like couple it to like a smartphone. So I use the power of the smartphone with a low level Arduino.
You ever played with the?
Yeah, I've never figured out like, you know, it's like a benefit for me or not.
You should touch bases with Jay Harrison. I tried to get him here tonight. He, that was his gig when he first started robotics. He, I guess, started with a company and it went viral. He sold it and moved on. But he is a very subject matter expert in robotics. And he's a member of BDPA. So if you're a member, you get access to him. You can look him up on the web too. His name is Jay Harrison.
And that last link is just showing the EE Times, the professional publication. They have a link of projects that people have done with Raspberry Pi, Arduino, and some of the other single board computing platforms. So like I said, it's definitely out there at the high end and at the educational level. And there's just a list of resources out there, just a few of the resources out there that's available on these devices. The best one for Raspberry Pi is raspberrypi.org and Arduino, arduino.cc. Those are your, I say, the two big sites. And the beagleboard.org for the beagleboard projects. Make use. That was where I picked up those videos from. And YouTube, of course, has tons of stuff on all the projects. And what's Instructable. Instructable is a nice site because they show how to do a ton of different projects. It's not even, it doesn't even be computer related. Instructable site will show how to bake a cake, sew, remove a stain, and then even up to using your Raspberry Pi, your BeagleBone. So that's a good site to check out if you want to get your hands into building and making at all levels. Again, just a few more sites out there. Adafruit, that's a site that sells components. And Element 14, they sell components of all of these devices and the different shields. And again, tutorials out there, Cambridge. Again, Europe's very high into this. And that's just my presentation, but let me show you the Raspberry Pi. So right now I have this one running what is called the Xbox Media Center. Now not Xbox and Microsoft, just Xbox and just Xbox in the sense that in Linux term, the graphical interface is called the X Windows system. So that's what they call it, Xbox. So they're not trying to infringe on Microsoft.
Yeah, this was that, and it has nothing to do with the project from 20 years ago where they pretty much hacked the original Xbox, installed Linux on there, and they had it going without pretty much little to no effort.
So this is the Xbox Media Center. So basically it's running on a Raspberry Pi. It allows you to access your network's music, video, and also anything on the internet. So this is a way that if you don't have the latest and greatest smart TV, or if you want to add smart TV to something in a garage or in an area where I don't want to put an ultra expensive TV, but I could put a low cost, then you get this low cost device to give you access to the content of the internet.
So how do you address the buffering issues with the movies?
I think that's gonna stay there until we get fast internet in America. That's really the main problem. That's the main problem is that we don't, Europe is already at 100 megabits and parts of China and Japan are at a gigabit. What we're at 20. 20 meg from
Yeah, but don't
Comcast.
we have to pay
Probably
extra.
And you have to pay extra for the higher speed.
Okay.
So that's really what's causing our buffering issue. And then also at Netflix during prime time, they take up what 40% of the bandwidth. So you do have to contend with that.
So to, I'm sorry.
Yeah, go ahead.
No,
So to connect this to a TV, you have to have a TV with a USB port?
No, HDMI.
Okay.
So that's what this is, right? So at least that's what I'm talking to these models, do the HDMI connector and just plug it in.
And then it just runs itself?
Yeah, once you configure it, then you can add the applications.
so you just need internet access.
Just the internet access, yes.
Okay.
Right now I'm using the cable because I didn't have time to set the Wi-Fi, but it will work with Wi-Fi.
So you programmed it to go to the, what is it, Pandora?
Yep, these are applications that you can see. I can get
Is
more.
that hard coded on that, in that machine or something? Or
It's
is it
actually
local?
going out to the internet. Some of it's hard coded, and some of it's within the distribution where you update it and it tells you what it can handle. And then other people are writing these little programs and adding them out to the software repository.
Right, so with this, you can make any TV a smart TV?
Yes,
Right.
yes,
Got it, I'm there now.
yes.
Come out the Stone Age.
So this is just to show you a few of the applications that are available.
That was his name.
And it's just on the music side. So this was the trend that we're trying to push many years ago with the set box TVs, which never caught on. But in the hacker and makerspace movement, this has been underground and been building. Because I have the, which one did I buy, which is Xbox, not Xbox, I'm blinking out which one I have. I remember the bit.
Is it neck gear?
It was the D-Link Boxy Box. It was the Boxy Box. Similar, it basically was a different version of this software. It was pushed about 3 years ago. D-Link bought the company because it was an open source company. They bought the software and the hardware, pushed it on the market. Then about a couple of years ago, they kind of just pulled support because they really could never sell it. Right? It's kind of like Apple TV. Apple TV's been up there a while, but how many people use Apple TV still? But it's one of those things, it's slowly catching up because Netflix is getting bigger. And people are going, oh, I want more of that content from the internet. So these media centers are getting more popular. Plus, they're building them into the TVs, which is Linux based. All those little apps are Linux based. They don't let you know that. But this is just one of the applications you can run. It runs a little slow on some things, but once it's going, it does a decent job. Like in Pandora,
I mean, but for the price you pay, I mean, I'm not gonna
yeah,
say.
for the price you pay, you're getting.
Can't really expect top quality.
Yeah, it gives you enough that
To enjoy it.
to enjoy it. Yes.
Well, since it's October, let's bring up the Freddy Krueger movie.
Sad story, I've never seen that one.
I've been telling you.
Yeah, I got cussed out that, I got, well,
Playing Pandora, which you usually get on the internet or your phone.
Well, that's cool. So much for my tumor.
consecutive TED Talks, or even I think you can go live to help us here. This going.
defending the town against ISIL's attacks.
So there you're getting Al Jazeera live,
advance for weeks,
which
but on Monday
cable,
it entered the
the
town.
Comcast tried
Turkish
to extricate
protesters
that
say
channel.
the Turkish government is not doing
Now,
enough
one
to
thing I
stop
noticed in
ISIL.
this version, it's only standard
Revealing
definition, so
clashes
on
between
the
the
big
demonstrators
TVs,
and
you see
Turkish
it's a little
police.
blurry. It's not
Almost
high
200,000
def
people
signal.
have fled Kobani and surrounding villages since the fighting began. Gordon Smith reports.
So right there, that's being streamed live.
From across the border in Turkey, it's clear that the battle for Kobani is more intense than it's ever been. Fighters from the
So that's just one of the features that you can load up and play with at home. And for $35, like I said, get a spare high-speed SD card, load up the image, and away you go. This version is pretty easy to configure. There's others that take a little bit more. So it's more than experimenting with which version to play with.
What is the maintenance like? I mean, once you set this up, like if you got your friend to come over and set this up, what kind of maintenance would you have
It
to?
shouldn't be too much maintenance because once it's running, if anything happens, you just unplug it, plug it back in, it'll reboot and start itself again. So that's what's kind of nice with the way the software is set up. It's almost maintenance free. So now let me. Shut this down. So right now I'm loading up what they call that noobs version that is on the website for Raspberry Pi. So it's going through all its Linuxy stuff, loading up and running. Being in some things, I just pulled the SD card that had the media center out, plugged in the other card, away you go. So Start X is the graphical interface. Good to load up. So right here is your graphical interface of the Raspberry Pi, the Noobs edition. So they have preloaded with a few things. If I plug in the Wi-Fi dongle, it will actually use the Wi-Fi adapter. Just a little, do I have it? Just a little dongle you can plug in that then wireless connect to your network. Scratch right here, let me bring that up. This is the learning environment for programming for kids and adults too. So really it's a good way for them to learn. If you're totally new to programming, this is a good way to play around and learn how to structure your code. Now, of course, there's tutorials on this online, so that's what helps also. And because you're on a computer, you can go online directly and watch a lot of those tutorials. This is for mathematics. That's actually, again, another program in the educational sector We're doing mathematical evaluation of a few other things. Then of course we go to internet. Because it's not the speediest, but because like for $35, think of what your first, think if you ever bought a computer for $35 there. Yeah, they can do anything with. So that's. We should bring up our website. But again, as a Raspberry Pi is definitely more for learning, teaching, I say all levels, youth, adult, programming, then also for experimenters who want to go in and interface with the real world. So there's our site coming up. So any questions? No? Yeah, it's one thing is just go out and try it. You know, go out, go to Micro Center, pick one up, get an SD card. As long as you have a USB keyboard or mouse lying around, plug it up and get a USB power supply for it. So definitely under $100. Plus, I believe also on the internet, if you even look at, there's a couple of Kickstarter programs out there that people are selling these whole kits for under, well under $100 or $100 even. There's everything you need to start up with the Raspberry Pi.
So I can like give me some business card and say, get rid of your cable. I can help you.
Yes, this is a part of the cable cutting movement. It just, of course, Comcast makes it difficult because a lot of times they're pulling a lot of their exclusive content and now you put it on the internet now. And they're putting it in there with their pay-per-view type system that they've put on their streaming system.
One more quick announcement from BDPA. Next week, Thursday, at the Information Exchange meeting, October 16th, which is a Thursday, from 6:30 to 8:30, they're actually talking about HP's Helium OpenStack Cloud Professional Services. That's another topic that we're talking about, and I believe in both situations you will have free food. And these will both take place at Techtown, 444 Burroughs in Detroit, Michigan, 48220.